All right, well, everybody, thanks for showing up. Tonight we're going to be talking. So we've had a stretch of what, 6 months of serverless. So we're gonna break the mold a little bit, and we're going to talk with HashiCorp. Ranjit, I'm sorry, somebody have a question? No. About HashiCorp, operating infrastructure as code, and all things therein. And I've got a bunch of questions. So did you want me to prep it in any way, or
no, I can
tee you up?
Jump right in.
Okay, cool.
So I'm going to talk about unlocking the cloud operating model. And at a high level, what is the cloud operating model? When you are mandated to adopt the cloud, you can't just buy some servers, put them in the cloud, and say, now I'm in Azure, now I'm in AWS. You have to really start thinking in terms of what the cloud is meant to do and how you can use it to leverage into your applications. My name is Ranjit. I'm a senior solutions engineer at HashiCorp. I know we've been talking very casually. Been working at HashiCorp for almost 2 years now. I'm in the Northeast, so visiting on the road with both Brian and Ed, visiting customers and helping them understand how all this stuff works. What we're seeing in the industry today is there's this transition towards multi-cloud or hybrid cloud. So we started here on the left with dedicated infrastructure in the data center, racking and stacking machines. And then probably somewhere a little over a decade ago, we started moving into private cloud, your VMware, your OpenStacks, things like that. And now we're thinking about getting even more dynamic by moving into all these public clouds. And the difference being is on this side, over the years, we've collected a lot of data. These are where your databases live, where your clustered file systems live. We call these systems of record. So all that data you collected, you probably have in your organization a pile of data somewhere in your data center. Like that data has what we call gravity, meaning it's really hard to move that data anywhere, and the bigger it gets, the more it's just going to sit there forever. On the right side, we have what we call systems of engagement. So today's style of apps, Web 2.0 and then some, mobile, tablet, all these kind of apps that we demand today, want us to be able to interact with that data, but in a way that's more user-friendly. So maybe I want to pull something on a phone, I want to access it from a website, I want to hit it with an API. I have a lot of it happening during the holidays, I have less of it happening during the summer. There's a lot of different ways where we engage with that data. So we're going to call that systems of engagement. So we've tried to find this to be very static on this side, and we'll talk more about what that means. But on these side, we want to put these in clouds so that we can have stricter timelines. We can get stuff on demand, we can burst, we can decrease infrastructure, we don't need it, that sort of thing for our dynamic systems of engagement. So I did end up taking the products out of this presentation, but we'll imagine this as Terraform. The first thing we think about when we're building anything anywhere is provisioning. So let's write the word provisioning in here. In the static data center, this is pretty easy. We have dedicated servers, we can rack and stack those, we can put SANs in, we can put NASs in, we have switches, we have firewalls, that's easy. When we get to the dynamic data center, we don't want to necessarily provision lines and lines of servers. We want to have those servers when we need them, and we want to dispose of those servers when we don't need them. So this kind of on-demand, come-and-go architecture, as well as serverless is on here. We want to do this without even servers. We want to be able to provision these things that don't have actual tangible infrastructure associated with them. So after we provision both of these scenarios, the next things that we're thinking about is put in this box, secure. So I've built some stuff, now how do I secure that stuff? In the data center, it's very easy. In the physical cloud, it's very easy. I have that castle moat kind of approach where I put a firewall around it and I put some rules on the firewall. If I'm on the outside of the firewall, I'm an unknown entity. If I'm on the inside of the firewall, I'm a known entity. I can start punching holes in that firewall based on IP address. If you're coming from such and such subnet or such and such IP, I know who you are, I can let you in. If you're not one of the whitelisted IPs, I'm going to say, I'm not letting you in. So again, that works on this side. But when we think about clouds, what's the trouble with using IPs in the clouds?
Dynamic.
Dynamic. You often don't even know what the IP is until after you've built the thing, right? So it adds this layer of how do I depend upon that? So we want to move away from IP-based security to identity-based security. Everything that you are building tends to have some sort of signature that goes along with it, whether it's a certificate, whether it's a profile, whether it's a user that it's running as. So based on that signature, we can still identify whatever that is without necessarily relying on the IP that it's running as. Next, how do we connect this stuff we're building? So again, on this side, we're relying on host-based networking, meaning I can say A can talk to B based on their IP address, I can put a route, I can add IP table rules, I can add VPNs. It's all very IP-based. But again, because IPs are changing and we don't necessarily know what they are, and we shouldn't have to when we get over here, we don't want to write rules and networking based upon IPs. We want to be using that service-based identity, meaning in the end, web should talk to data, or ingress comes into DMZ, or API talks to database. We're going to start thinking about service identity. And then the last part is, how do I get my apps onto that infrastructure that I've built, that I've secured, and that I've connected? On the static side, we often have one application that's on one stack, meaning I deploy something like a LAMP stack. It runs my WordPress blog. I deploy an IaS server, and all that does is web. I deploy a SQL server, all that does is database. But there are a lot of funny statistics out there about if you look at a mainframe server, for example, people have calculated these numbers. How much is the average CPU of a mainframe server, you would say?
I think it's less than 20%.
Average CPU usage?
Yeah.
It's actually north of 99%.
Oh yeah, because the dedicated
Because it does, yep, it does what it's supposed to do, and it's doing all of it constantly and just that. But because it's built for that one thing, and it's doing that one thing, we can't really flex it to make it do anything else. So we build, instead of mainframes, we decompose into physical servers. And I think this is what you're talking about. The average physical server CPU usage is somewhere between 20 and 25%. And why do we do that? Because we don't want CPU to max out and that server to fall over. So we always build in a little bit of extra, usually north of 50% extra, so that if that server fails, that workload can be moved to something else that has 50% still available, right? And then when we get into VMs, that number goes down a little. When we get into containers, that number goes down even more. And when we get to serverless, there's no notion of CPU maxing because it's running on some pool of infrastructure we don't even see. So over here, we're very stuck on the machine that we deployed on. Over here, we can schedule a fleet, meaning I have work that needs to be done. I can just sort of throw it out there. It can be on VMs, it can be on physical, it can be in containers. I just need that work to be done. So I schedule that work on a fleet of servers. Maybe I increase that fleet when necessary, and then I decrease that fleet when it's done, like batch jobs or something like that. That's the kind of work that I'm dealing with. I like to talk about my team actually. We talk about the Uber example or the Lyft example. If you bring up Uber or Lyft on your phone, it doesn't all come up right away. It tends to fill in dynamically, right? Maybe the first thing you see is the map, and then maybe a half a millisecond later, you start to see cars appear on that map. Then maybe some of the other things start to fill in. If there are coupons available, that will pop up and say, hey, you're eligible for an offer. It's probably going to let you know if your credit card that's on file is expired. All these things, probably each one of those things that are popping up on your phone is some sort of service on the back end that has been created specifically for your session. So I pull out my phone, I open up Uber, workloads are spinning up. All I see is what I see on my phone, right? So we want to think about things like, do I need this long-standing infrastructure for when I open this app on my phone, or should that come up on demand and as necessary? Now, if we think about security, for me to authenticate to my account, there's probably some database that's there. There's probably some token that's on my phone. Should that be some sort of long-standing username and password that is always the same every time I open the app? Or should that be some sort of credential that when I open the app on my phone, it logs in, it authenticates, it gives me a token, and then when I close the app, some period of time later, the token expires and the authentication is null and void, right? It doesn't need to be that long-standing credential. When I'm connecting from those systems of engagement to the systems of record, that tunnel that exists, that has to be encrypted, right? I don't want to transfer any sort of personal information, credit card information from this device back home, right? So I need to create probably some sort of mutual TLS tunnel that takes certificates, that takes keys. Do I have a SSL or certificate that has a 5-year expiry just for the 5-minute session that I'm on my phone? Or do I create some certificates that will last the lifetime of my session? And then when I close the app, those certificates can expire and there's no tech debt, there's no collateral lying around. Things like that, right? So these are the kinds of things we want to think about when we're operating in the cloud. It's not just a matter of lifting and shifting your application into the cloud. And what I mean by that is we're very used to, I have load balancers, I have subnets, I have zones, I have servers that do one operation. So I'm going to build VMs that do one operation. I'm going to put VPCs around that. I'm going to put ELBs in front of that. If we end up building exactly what we built in the data center in the private cloud, in the public cloud, we end up running into the same headaches that we did before. In fact, we give ourselves more headaches because now we're using the tool in the way it's not meant to be used. Make sense?
Yes.
Any questions so far? Do you all remember what goes in this box? Security. Yeah, okay, good. So over here, we tend to go very ITIL, and we're going to explore this a lot. It's very ticket-driven. And over here, we want APIs and self-service, and I'm going to mention this more and more as we get into it. We have a really good banking customer that used to do back office and is trying to move front office. And what that means is we can't just have piles of data that are stored in Hadoop or in stacks of shared disks. We need to make it user-friendly. We need to be able to present it to the users. So this sort of front office applications is where those system engagements really come in. We're going to talk a lot about self-service, meaning if I am an operator who is, I don't know, we're adding a new farm of servers and I need to update a list of IPs in a firewall. Traditionally, someone's got to open a ticket. That ticket comes to me, and then I have to fulfill that ticket, edit the device, mark the ticket as closed, and then report back to the customer of mine that your job is done. If all the information is not there, I have to write back and say, actually, I need you to go get approval. I need you to be more specific. And this ticket exchange goes back and forth for who knows how long before it's actually implemented. And my manager was saying just today, if I have to take care of 10 databases or 10 firewalls, like at first it feels good because I have all the power, right? You can't make a change unless you come to me. Like, so you got to be nice to me. I take bribes. Brandy is good. You know you are getting
recorded, right?
Yeah.
So be careful.
I'm not an official AWS certified speaker, by the way. So yeah, that feels great. But now if we go from 10 things that I manage to 20 to 100 containers to thousands of containers, I don't want to be the person satisfying all those tickets. Nor do I want to necessarily just hire a bunch of people who all they do is satisfy tickets. That's not a job most people like to do. Probably get some interns. But if your job is just tickets after tickets after tickets, right, it's going to get very error prone. It's a lot of human clicking, it's a lot of human error. So cloud adoption, we need to change that style of thinking again. We're going to talk about how we get rid of some of that ticketing and move to more API-driven workflows. Anytime we change the way of thinking, if we say we're just going to adopt DevOps, right? That's not a thing that means I'm going to buy Terraform and now I'm doing DevOps, or I'm going to buy Vault, now I'm doing DevOps. There's more to that changing of the mindset. So the first thing is people. People have a strong play in what we're doing, right? People want to do things a certain way, they think a certain way, they have skills, they have a culture. That's the first thing probably, right? If your people aren't thinking in a DevOpsy style, you're probably not going to get anywhere even if you put the magic toolbox in front of them, right? I just don't want to use it. The next thing is process. So after I have people on board with what I'm thinking about how I should operate, I need to have processes that make that easy to do, right? How many times have you built a thing and you think it's the wonderful, awesome thing that's going to fix everything, but because no one knows how to actually use it, they just ignore it, right? We need to make sure that it's built into what they're doing, they're familiar with it, there's some process around it. But then the last part is, to build those processes, we probably have to build some systems. So this is where actually the tech is. I can build systems with Terraform, Vault, or Console, but that's not enough. I need to have process around it, and I need to have people engaged in it. So we tend to decompose this into these 3 layers. We'll go into that a little bit more. So talking about the people, if you want to specialize in every tech and have someone that can do anything and everything, we have the unicorn, right? Try to hire the unicorn. If you can manage to find 1 unicorn, that's awesome. If you can manage to find 2, someone's lying to you, right? So we can't just rely on hiring unicorns who just figure it out. So we start separating roles. We have folks that do developing, operations, networking, and security, but they actually have to now sort of change a little bit about how they're thinking. So developers, they tend to, we always make jokes about how developers like write an app and throw it over the fence, and it's up to you to deploy it. Some of that probably has to change. Operations folks have to learn something about development because now we have sort of infrastructure as code and these practices that we kind of borrow from development. Same way they're going to borrow some of what operations are doing. And this SRE role, I don't know, the SRE role I don't think existed.
So what is SRE full class?
Site reliability engineer.
Yeah. It's, I thought at first it was a fancy way to say someone who does monitoring. Right? But it turns out it does encompass that, but it's someone who's doing operations in a more DevOps-y way, using all the tools that we have today. So I think this role was born maybe in the last 5-6 years. Like we didn't have SREs a decade ago. So this role is emerging. Networking folks, imagine if you were a networking sort of person in the data center, in a VMware, where you definitely have vSwitches, you have maybe cords, you have things you're logging into directly, editing rules, and then we say, hey you're going to learn cloud networking, go. Right? You have a different style of thinking. You can't do that just the way you did it before. You have to think about, okay, services versus IPs, things like that. And then security, like we talked about before, applications, they may move from one cloud to the next. They may move into containers. How do we make sure that its identity is still there when it moves from one place to the next? Auto-scaling groups, they're doing this, right? All day, every day. How do we make sure we maintain a sense of identity? So we want all these people to chat with each other, work together. This is where that DevSecOps really comes in. What it means is now silos of people that were doing stuff before now probably have to collaborate. And we can put some process, in fact, for all the groups involved, we can put a similar process so everyone's kind of doing the same thing and it's not too different because we can start codifying and build in version control, things like that, things that infrastructure as code can give you. Otherwise we do this. We have the compute team, the firewall team, the load balancer team, and each one of these has an interrupt. These guys do their job. They hand off to some of you guys are smiling and nodding, right? And by the time you get finally to the load balancer team, these guys make it go live because they're adding your IPs into the mix. What does that look like? What does that time to value look like? So if
Basically, by the time you reach the end, the business is pissed off because it's not what they asked for.
Yeah, that's the classic, the memes where you see like, this is the instructions given to the developer, this is what they made, this is what ops does, and this is what the product team is trying to do with it, or whatever, yeah. So if you're not afraid to say, what are some of your all's time to values that you have out there? When someone asks you to deploy a thing, when does it actually get out there?
It's got, and you were talking about like 4 places where it could be failure after failure after failure. And you have the software development life cycle curve, right? the
Yeah.
quicker you find the bug, it is
Yeah.
there. Looks like
Iteration, yeah.
this seems to be like a hockey, like a inverted hockey curve kind of.
Yeah, yeah, that's true. There's probably, like you're saying, iteration that happens here, and then when you have some sort of artifact you can hand off, iteration happens here. And iteration is a good thing, but when it turns into pinball, meaning compute team goes to firewall team says nope, try again, and then they work on it, they go here and says nope, try again, then they get here, load balancer team says nope, go back here, adjust something, and when you start doing that is really where you lose time. You lose a lot of time, right? So you want to avoid that. Here's a good example, major telco, 72 steps to get something out in the field, and that's tickets or processes. So imagine how long that takes, 10 months, just to get something launched. And like you're saying, by the time you get it out there, so much has changed, it may not even be the thing you wanted back 10 months ago, right? So what we start working on with that sort of siloed, sort of waterfall time to live kind of thing is, first of all, the ownership. We tend to have a team that's in charge of the firewalls, a team that's in charge of VMware, and we break up stuff based on technical domain. And then we have gates in between those domains. So this is how we're used to doing it. So firewall team, VMware team based upon the technology. So you specialize in that technology, which is probably good because now you know anything and everything about that tech, but it means that everything you know doesn't really apply to anything else the organization is doing, right? You end up getting siloed in your technical domain. What we want to move to is process ownership, meaning I'm not necessarily the firewall person, but I'm the network security person. Or I'm not the certificate person, I'm the secrets management person. Because these domains are now not just single text, but they're workflows that encompass a little bit more than just that one thing. And then between those workflows, we can apply self-service, API-driven development. So now the handoffs between workflows, we'll see, are something like this. So we have a provisioning team. Notice this is not the VMware team, or it's not the AWS team, or the Azure team. It's the provisioning team. Because they have a workflow exposed through an API that it really doesn't matter what it is. You come to them, you hit their sort of storefront, and you get a thing, and it's all the same. Deployment team, again, it shouldn't matter whether you're launching into a cloud, containers, serverless. That deployment should be fronted by an API where someone can request something, put an input in, and get an output out. And the security team, again, this is not the SSH key management team, not the TLS team, not the database credentials team, it's the security team, because all that kind of stuff can be front-ended with an API. What is an API? API is basically a contract. So imagine you go to, what's a terrible experience?
Comcast customer service.
You go to Comcast, yes.
That was right at the top of your head, wasn't it?
That comes up a lot.
about it.
The DMV comes up a lot. But I like Comcast. Let's go to Comcast. Imagine you call up Comcast and you want to sign up with them, and you want to get the triple play or whatever. You're calling them because you want to give them money. You call them and they say, "Give me this information, and we'll get you signed up." So you give them the information, they say, okay, we'll get you signed up and we'll be out there tomorrow. Then they don't show up tomorrow. You call them and they say, actually, we need this information as well. You give them that information, we're sorry, we'll show up tomorrow. They don't show up. You call back, we didn't need any of that information, we need this information. So these sort of information exchanges happen. This is what ticketing looks like too, right? The information required is not clear sometimes. An API, the first step to an API is let's document exactly what the inputs are, and let's document exactly what the outputs are. So now if you can go to Comcast and fill out a form on their website, that gives you more of a belief that they're asking you all the things that they need, and then when you fill out the form and get a confirmation code back, that gives you some confidence that you've done it correctly and they've accepted your response to some degree, right? So that API is that contract. Again, what happens underneath here, you don't know, but as long as they give you the same set of inputs and outputs, Everything that happens below that is sort of black box. You don't actually need to know what's happening there. I give you a server operating system, I give you a memory requirement, I give you a CPU requirement, you'll create it for me. Maybe I don't care if it's in Azure, AWS, or what, but that's that contract, which is the API. Oh, and these systems, when we talk about people, this is a people layer, this whole thing is the process layer, and this thing in the dotted rectangle is the systems layer, from the decomposition of people process systems that we did before. So here we are in our systems of coordination. Again, team to team, we want to get rid of this ticket queue and put some sort of API-driven system. What that means is at any point, if I have the right set of inputs, I can give you a set of inputs, you can do a thing, return an output. And that is the starter to self-service. Of course, at this point, what's the next problem with self-service? Anytime if you were to say, hey kids, here's the candy closet, it's all advertised, feel free to help yourself.
Governance.
Yeah, so
Governance,
of course
right?
now you have to start thinking about how do I put some guardrails around that, put some rules on that, maybe only one candy bar per day, something like that. So that's something that you can decide in the process that you do, but the main thing to get started is that you have some sort of API-driven system self-service that's allowed. So now this is like this. People with the changing skills are learning about automation. We have process with self-service. It's more about the workflow, not the technology stack itself. And then the systems that we build are now deliverable through APIs, so that now they're cross-team available. And the good thing about APIs is if you have a company where everyone constructs the same sort of API or the same style of API, no matter who you're dealing with, you kind of know. We're going to call it name, we're going to call it type, we're going to call it memory, we're going to call it Vim instead of Emacs. You know, if you make those sort of high-level decisions on what your API looks like, as a company you start to function better. Even if you're moving from one department to the next, you're kind of comfortable with the language that everyone's already speaking. If we get to this point where services internally are provided by APIs that kind of speak the same language. So let's talk about some buzzwords. So infrastructure as code means a lot of things to a lot of people, but generally in this workflow, when we write something up and we need infrastructure, create that ticket, submit it to operations, and then they go do something with that. Maybe it's going to vCenter, maybe it's logging into the AWS console. But what we want to do is give them an API where they can write infrastructure as code, and then it gets done. What we're doing is splitting the execution from the definition, meaning if I write a set of declarative code, which is infrastructure as code, that in itself doesn't do anything. It gets applied to an engine that does something, right? So for example, if I write a bash script or I write a Python script, you can't really necessarily look at that script and tell me what the outputs are going to be, right? You probably have to think through it. You have to do some math, some calculations. And also, it depends on what's already there, right? If you have a Python script that says create 5 things, and I ask you how many things do you have in the end, what's the answer?
You do not know reliably, right?
It's 5 plus whatever is already there, right? Who knows, right? If you have infrastructure as code, it's more of a definition that says I want 5 things. So if I have 5 things already there and I run this code, what do I end up with?
New 5. Depending on
Yes, that could be an answer. I either create a new 5 or I say, I already have 5, you wanted 5, guess what? We're good. Right? That's the idea. The definition is separate from the execution. What that gives us is very repeatable, very consistent, and it's documented. If we have a good DSL, a domain-specific language, it should be very human readable. You should basically be able to read that stuff without knowing, without studying it first. It's very, okay, this equals this, number equals 5. It should be very easy to read. And that in itself, if you know that code ran successfully, that almost means that that code is now the definition of what's out there because it's reliable. Make sense?
Mm-hmm.
So now let's talk about security. That was provisioning. Let's talk about security. This is where we start. One web server, firewall, database. Typically what we do is in our firewall, we just add a rule like this. This IP is allowed to talk to this IP. But you can imagine that that changes into more than just one. So that list is now 3 combinations. And as you go to more and more, how many combinations of web to database do you end up having? Do any of you operate with spreadsheets with lists of IPs in them?
Most
Have you
network
seen
people
that
are like
though?
that.
Oh, yeah, sure.
Yeah, right? So where does that get you? Is that when you look at, if I were to just show you this is you logging to a firewall. If I were to just show you this, does this mean anything, right? Does this tell me what's actually going on? So if I said, hey, this 3 to 2 rule, like what is that? Can I get rid of that? What would you say?
Depends.
Depends, right? Probably better to just leave it there so I don't get fired, right? So you can imagine this list goes on forever. Each part of it is meaningless by itself. You have to have some sort of knowledge of what's going on for this to make sense. Firewall lists tend to grow and grow and grow because it's just easier to just leave it there. Why even risk it? We want to move away from that, and we want to do something like this. If you were to look at this and log into a device and see this, can you make sense of this? This means web talks to DB. That's easy to understand. The way we're achieving that is we need some sort of registry. What a registry is doing is discovering what the web servers are, discovering what the database servers are, and saying, if you're a web, you can talk to a DB, and I'll keep a track of who you are, where you are, what you're doing. So that allows us to have a simplified set of rules that's service-based rather than IP-based. And you can imagine this doesn't change too often, right? Web talks to DB, how often are you going to change that? Versus how often do you have to change this? This changes often, right? So what we're doing is this gives us our ability to enable dynamic infrastructure. So things are changing, IPs are changing. We almost want to think of IP as a throwaway value. It should be something in the end that we're not worrying about because we may not even have an IP that we're dealing with that is a known value, right? Zero trust networking. How many folks have heard that term or work in a zero trust area? Yeah. So in the data center, in the private cloud, we have hardware that we bought. It costs a lot of money, and we want to use it, probably CapEx. In the cloud, we're spending money on a pay-as-you-go model for infrastructure that we'll never see, infrastructure that we'll never touch. We don't know what it is. It's commodity hardware. It's not commodity hardware. The fact is we don't care. So we can't rely on a network that is hardened in the way that we know because that network is just a flat network, right? When you sign on to a new Azure account, AWS account, it's just a flat network of things we don't even know about. Who knows how many switches, how many hops? But we can still build on that with a service-based architecture rather than this host-based architecture. Oh, I missed this slide. Anyone deployed a service mesh where they work? Yeah, so service mesh would be building a layer of abstract service-defined network on top of your architecture. And the table stakes for that sort of is to first, like in the previous diagram, is discover where the services live, and then we can start to get them to talk to each other. With something like console, we can have things discover each other, talk to each other, no problem. In some sense, we can eliminate load balancers and firewalls that are service to service, right? We still need load balancers and firewalls to go out to the internet to engage users, but things that are within the data center that are going service to service, to some degree we can eliminate load balancers and firewalls. But if you say that to any of your network people, and you say, hey, by 2022, we're going to eliminate all internal load balancers and firewalls. Good luck. That's not going to fly. So the first step that you want to get to is automating your middleware. So rather than having someone, rather than have someone receiving a ticket, going out to a firewall or kicking off a bash script and manipulating that firewall, What we want is a system that will recognize when a new web server comes online and dynamically update a firewall list, dynamically update a load balancer. So if that's happening in a dynamic nature, I'm not relying on this human event to run a script to update a thing, where my time to live is shortened by how many people are working today and when does so-and-so get back from lunch, okay? And then securing multi-cloud networks. It's really hard just out of the box to get on-prem to talk to cloud or cloud to talk to cloud. We end up standing up tunnels. Anytime you stand up tunnels, now we've introduced certificates. Key management's a fun problem. A lot of times when you're birthing a key, you put a 10-year expiry on it because you know you're probably finding a new job by then, right? So you don't have to deal with it. Who's done that? Yeah, you liars. Yeah. Key management is a funny thing because it's actually, in the end, it's easy to swap a key, but we don't do it often enough that we develop a muscle memory on how to do it. So every time we push it off, we don't want to do it, and then finally when it's time to do it, it's just like, do it, like stay overnight and get it done. So why should key management be so tough? It should be something that can be automated, so why not automate it? So this is where we get into service meshes. Another buzz term is the container. So containers, when some people hear the word containers, they think it's the future and it's the solution to everything. But in fact, it could be, but really what it is, it's a portable deployment unit. It's something that you can make 10 of or something that you can make 1,000 of, and there's no difference in doing that. But to get an application to a point where it can live in a container is a process. Some applications lend themselves to that. Some applications are very hard to containerize. And in fact, your organization will say, let's not even go there because it's not worth it. That app is so old, it's not even worth refactoring. We all have those, right? It's legacy. So we have that developer, again, let's throw out a ticketing queue and let's get someone to deploy my containers or what have you, whatever the application is. And of course, we want to replace that with an API. This would be our product Nomad. And what Nomad can bring to the table is we don't actually require you to containerize your app in order to deploy it the way you would deploy a container. You can schedule or deploy C#, Java, Ruby, Python, as well as Docker containers all the same way. Every operating system actually has built into it the notion of containerization. Docker, for example, was just built upon that, but every operating system is capable of doing it, so we've built upon that so that now we can containerize basically anything. Yeah, so we want that containerization or that workflow to schedule applications, no matter what it is what gives power to your end users to be able to go deploy and then subtract workloads or schedule a batch, on and off, burst, shrink workloads, all that kind of stuff. And this is a way we can do even that in infrastructure as code, where we can write a specification for what containers we want, what type of image we're building off of, how many, and things like that. So in a way that we can repeat the deploy of containers or applications in a way that, again, if I look at the code, it's not the execution I'm looking at, it's the definition of what I want that I'm looking at. So it's very clear and repeatable of what my end product is. So down here on the bottom, we have teams that are controlling infrastructure. All these teams, one thing that I'm thinking that this diagram could also have is you probably have APIs in between these teams as well, not just for your outgoing customer. But the point of this diagram is that team, as a developing team, comes in to this point with an application, and then these supporting teams can offer an API so that they have the 3 prongs here to get what they need to get this done. Let's provision some stuff, let's get it out there, and then let's make sure it's secure. And those are the 3 biggest challenges we see for getting an application out in the cloud or what have you. How is this slide different?
Observability too.
You had a different.
Yeah.
It's a joke because it's about observability. Yeah. So after you deploy anything, right? If I were to ask in your orgs, how many containers do you have, or how many VMs do you have? Sometimes that's a hard question to answer. I don't know if any of you know off the top of your head, or you know where you can go to just easily look that up. Yeah? No?
Yeah.
Yeah, okay.
Sure.
So that's at this developer team layer where we need the developers to know, not just down here, but up top, having developers not only have an API into getting this deployed, but also to go back and view what they've deployed, where it's running, what's going on with it, is it healthy, is it not healthy, providing that observability. That's the feedback. Not only can I deploy, but I get some sort of feedback as to what's going on. And that's an important part of the API layer too. It's not just to give someone a tool to do something, but to provide that instant feedback as to now what is going on with the thing you just tried to do. That's pretty much what I covered here, letting them know what's going on, and then now having microservices becomes very important because instead of maybe for my app just deploying one container or one application, you may have decomposed your applications into 50 microservices. So now it's very important to know what's going on, what's running, what's healthy, what's getting taxed, what's not being touched. And having that observability sort of pushed out to the developer will give them information on how they may need to refactor their application rather than an ops team later on discovering that CPU is pretty high because of some process and then sending that to the developer. Let them discover it and give them the tools to do so. Navigating the transformation. This is the okay, that sounds great, but now how do we do it? So this is what you might get from your CIO, right? Let's do cloud, let's do DevOps. Has anyone ever heard their CIO actually say, let's do DevOps?
Yes.
Or do the DevOps? Yeah, it doesn't mean anything, right? So they'll say this. But we need to take this ITIL organization and we need to know exactly, we have to have some idea what we're doing it to do the DevOps. But then what if they tell you this as well? It's like, we want you to do the DevOps, but like we still need to be healthy, we need to make money, we need to retain customers, so don't actually break anything.
In a company, they call it perform and transform.
So it's perform and transform?
Yeah.
Nice. So do it, but don't break anything. Don't actually do it until we're ready to flip the switch, and even then, we should be able to flip the switch right back in case it breaks. This is a good one here where we've got our cave people on the right here, and they're just, they're too busy to notice that there's this cool thing called the wheel out here. 'Cause let's just do business as usual. I don't know what this is. I don't know if it'll work. I can't be bothered, right? This is where we don't want to be. And when we talk about bringing on automation tools, one of the arguments well, we've got people who know how to drag this thing across the floor. If we bring this in, doesn't that mean that they're out of a job? No, it turns out that these people know how to do things. They're just stuck in this thing all day that they never get to do the things that they actually can do. So you actually free up their time and let them do other things that we need them to do, right? More automation. Maybe make a better wheel. Right? So it's not happening overnight. We like to say that your ITIL stuff is not going to go away, and you're gonna rely on it to some degree for a while. Well, we'll call this some tree that's already planted, and find something new that you can do. This is your sapling. Find a greenfield initiative. Find a group that's willing to try something new. We find that there's usually at least one or two groups that are willing to try some new type of style of doing something. And what happens is the folks over here will say, hey, what is that you're doing over there? That's pretty cool. Can I try some of that? And so slowly this migration will start happening. And this probably will never go away. But at least you'll minimize it to some degree because again, back to the first slide, those systems of record, that mountain of data that's got gravity to it, that's probably always going to be where it is right now. You're not going to think about moving that data. It's just too painful. It'll probably cost a lot of money, or you got to call up Iron Mountain. And you guys know this, they'll show up with a truck of drives, and they'll copy everything, load it in a truck, and drive it to the destination because it's faster to do that than to copy over the wire. So you're probably not going to do that unless it's an edge case. But you're going to minimize ITIL and grow that sapling of your DevOps into more of a tree as time goes on. You really do need executive sponsorship because it's not just purchasing tools, it is that people process systems. So someone really does have to say, not just we're going to do the DevOps, but we're going to bring some folks in, we're going to educate, we're going to create some new systems, and we're going to train our people, and we're going to build some new systems. There has to be sort of that top-down mandate. At least this is where we find that it's most successful, right? If you try to shadow ops it and have a team do Terraform and then go build up from there, it doesn't tend to work unless some executive's going to say, yes, we're going to mandate Terraform, something like that. These business groups, because we talked about how it takes business groups to interface with each other over APIs, there has to be some alignment within the business groups and across business groups that I'm no longer going to slack my buddy over in the firewall team to get a change done. I'm going to go through an API-driven process, right? It's good to still have your buddy on the firewall team, but that can't be the way that you get stuff done on a daily basis. And then lastly, these people, modern practitioners, you may be able to bring in expertise via training the people that you have. You maybe have to hire from external and bring people in. These people might be a little bit expensive, maybe compared to the people that you have, but it's important to at least have people who are familiar with some of these new concepts and tools to at least inform the people that you already have of what we can do and get some ideas going, get some project management. Again, so you can take that sapling and grow it into a tree. Not happening overnight. So in conclusion, remember people, process, systems. This is doing the DevOps. People, I said some of this already. Yeah, cloud native, investing in training might be expensive. You'll also have people that just don't want to do new things. You have to manage that in however way you can. Process, anytime you have a ticket queue, try to think of where all those ticket queues are and try to pick off some of the easy wins there. What are some of the ticket queues that might be the easiest to automate first? It's not, again, right? It doesn't have to be an end-to-end. It could be one here, one here, one here. But over time, you'll get that done. And then the systems. Something that supports, we have the word heterogeneous here. Again, because we see that move from single cloud to multi-cloud, hybrid cloud. So HashiCorp has a variety of heterogeneous tools. That's Terraform for provisioning across any of those platforms. That's Vault for securing across any of those platforms. Consul does the networking across any of those platforms. And then Nomad, finally, for actually deploying your application artifacts across any of those platforms. And this last slide here is about the journey. We're still seeing people that are trying to adopt VMware, right? And you know what VMware did that even like sucks more is they said, let's put VMware in AWS. So now people can keep doing VMware, but they're doing it in AWS. And that kind of like boggles my mind. Because again, the whole point of moving to AWS and the cloud is to stop doing the stuff we did over here and let's do it new and let's do it the future way. So that's going to take time. Be sure you're willing to jump on the journey because it's going to take a while, but we can do it. A lot of people have done it, and we're here to help you. And that's
wow.
Any questions?
Yeah, we got time for Q&A.
So like you were talking about like IPs as kind of like